Capital accumulation. In the long run, we must allow for capital accumulation for interaction through investment between changes in output and changes in the capital stock. There is still a stationary state corresponding to zero growth, but the equilibrium concept appropriate to the long period is some rate of growth over time, and in particular a steady state growth in which all variables grow at the same current rate. We start by assuming that the capital stock K is a directly measurable concept. This is the assumption now made. Output Y and capital stock K alike comprise a single homogeneous commodity. Capital is the amount of the goods not consumed, and investment is the process of allocating output to the capital stock rather than for consumption. Further, capital must be perfectly malleable input in production, taking whatever shape is required. The technology of the economy can be summed up in some form of production function. Y is a function of KL at any given time. Here Y is the net output for input K of capital and L of labor, and to match this net concept, investment is taken as the net addition to capital stock. The technology of the economy can be summed up in some form of production function. Y is the function of KL at any given time. Here Y is net output for inputs K of capital and L of labor, and to match the net concept, investment is taken as the net addition to capital stock. As capital accumulation takes place and the variables follow their time path, so the technology of the economy may change. Hence, in general, we must write a shifting production function. Y is a function of K, L, T, where Y, K and L are all functions of time, where T appears explicitly to allow for the shifting technology. This formulation makes clear the threefold motive power of a growth in output, the accumulation of capital, growth in K, expansion of the labor force, growth in L, and technical progress shift in F. Capital accumulation is an essential and endogenous, that is, given element in all growth models. The other factors, more labor and better technology, may be considered as exogenous, that is, has to be found out. Influences and are so treated in our models as they are introduced. First, the expansion of the labor force and then technical progress. The growth in the labor supply and technical changes may provide the momentum, but the capital accumulation is the vehicle of economic growth. The two leading variables we take in our models are output, that is income Y, and capital stock K. The others following when these are found. The growth rates are 1 by Y dy is equal to d log Y, and 1 by K dk is equal to d log K. Then the net investment is simply the increase in the capital stock, that is I is equal to dk. So 1 I by K is equal to 1 by K dk is equal to d log K, represents both investment as a proportion of capital stock and the rate of growth of the stock. We look for steady state growth when both Y and K grow at a constant proportional rate. So steady state growth means where both Y and K grow at a constant proportional rate. The same rate for each variable. If the common rate is G, called warranted rate of growth of the steady state situation, then d log Y is equal to d log K is equal to G, giving on integration log y is equal to constant plus gt, that is y is equal to a e to the power gt, a being constant of integration, and similarly for k, giving the initial values y0 and k0 at time t is equal to 0, y is equal to y0 e to the power gt and k is equal to k0 e to the power gt. Further, since I by k is also equal to g, we have I is equal to I0 e to the power gt, where I0 is equal to g k0. All variables grow exponentially at the warranted rate g from their initial values at t is equal to 0. Thank you for watching. Please subscribe.